This will be our video on defining arithmetic sequences. So an arithmetic sequences are formed by repeatedly adding the same number. Addition is one of the basic arithmetic operations, by which we mean addition, subtraction, multiplication, and division. So when we're adding, we call this arithmetic sequence. If you pause and think for a moment, you might remember that if we just repeatedly add a number, we get a linear function, the function of a straight line. So this means a lot of things that apply for linear equations, linear functions, also applies to arithmetic sequences. So this number that we repeatedly add is called the common difference and referred to as the letter D for difference, and can be found by finding the difference between consecutive terms. So here we have D is equal to AN minus AN minus 1 for all n. Remember that n is just any number. So AN means any term, and n minus AN minus 1 means the term before that one. So any term subtracting the term before it. So let's look at some linear or some lists of numbers and identify if these are arithmetic sequences or not. So to notice that we have 1, 5, 9, 13, 17. And even though our sequence starts out front, I'm going to start at the very end. And I'm going to say 17 minus 13 gives me 4. 13 minus 9 gives me 4. 9 minus 5 gives me 4. 5 minus 1 gives me 4. So because all of these have the same difference, our common difference is equal to 4. Now, what I find many students feel is more intuitive is to ask ourselves, if we start with the first number, how do we go to 5? Well, we add 4. To go to 9, we add 4 again. To get to 13, we add 4. To get to 17, we add 4. So because we're adding the same number each time, our common difference is 4. So let's change our color here and do another example. Now we have 1, 3, 6, 10, 15. So to go from 1 to 3, we add 2. To go from 3 to 6, we add 3. And so we can immediately stop. This is not arithmetic. As soon as we have different numbers, we can no longer have a common difference, because common differences must all be the same. If we look at this third example, to go from 2 to 4, we add 2. To go from 4 to 6, we add 2. And to go from 6 to 8, we add 2. So far, it looks like it's going to be a common difference, an arithmetic sequence. But if we go once more, 8 to 16 gives us plus 8, or we can think of it as times 2 rather than plus 2. So the pattern is broken, and this is also not arithmetic. Whenever we're given a list of numbers and asked to identify if the sequence is arithmetic or not, it's important that we test all of them. If we find conclusive evidence that it's not arithmetic, we can stop then. But until we test everything, we can't say with complete confidence whether or not it's arithmetic. In our next video, we're going to look at expressing arithmetic sequences as functions with an explicit rule. So this about wraps up our first video on specifically arithmetic sequences and the second video of this lesson.